Good morning, good morning. Welcome to the Garden of Apologies, Pepper School. I am Eric. I am your Barmy Farmer. This is episode 8. Today's a special episode. We're talking a little bit about plant genetics. Peppers are nightshades, and although the peppers have both male and female parts inside the flower, they are self-pollinating. They are also cross-pollinating. We've got a bit of wind like we have today on a particularly windy start of autumn day, and the pollen just cascades around. We also have our friends the bees, who like to fly from flower to flower. They bring the pollen as well. And although you plant what you plant, you may not get what you think you planted. So I'll start today with the ghost peppers. Let me flip you down here so you can see my handful of pods. Got you slightly off center on the tilt, so you're getting a fun angle. These are all ghost peppers, assuming I can hold them. They're all ghost peppers, and ghosts, like other pods, other peppers, sometimes they will spontaneously ripen to the wrong color. So let me show you an example of that here. So these are both white ghost pods, but they are from different seed vendors. I have a nice, smooth, small pod here that came from White Hot Seeds. This larger, gnarlier white pod came from, I believe this year it was Refining Fire from Jim Duffy. But, you look at the styles, you've got a smooth pod here versus a gnarly, bumpy pod. So, slightly different phenotype. Just to make it a little bit goofier, this pod here, this nice peach-looking pod, with the same gnarliness, the same bumping, the same general characteristics as this white pod, but one fewer slug hole. But this happened spontaneously. So this was a white pod, white pepper plant. The plant beside it, from the same seed stock, produced this peach pod here. And then this white pod here is from a different seed vendor. So they are 3 pods that are completely different. And then just to twist it up a little bit, this is a peach ghost I've been growing for the last few years. It's got many of the same characteristics as the new peach ghost, almost the same color, the same gnarliness. Well, there we go. And then to make it even more complicated, I'll throw in a yellow ghost. And then we've got our standard red ghost. And then to complete the deal, we have a chocolate ghost. So the peppers all have basically the same genetics, but they are ripening to different colors. Sometimes spontaneously. How about that? So it's hard to say where the origin of these peppers are, who created them, who was the first person to find them like this, because they happen all the time. With my own garden, the Garden of Apologies here, I had a peach ghost pepper ripen to a white pod, and I called that a white peach ghost the last couple of seasons. This year, spontaneously, they flipped back to white. They flipped back to peach. So it was peach that then ripened to white for a couple of seasons, and now has flipped back to peach. Peppers are weird. The other thing I want to show you about peppers being weird, just to touch on genetics, that when I was panned down, you may have seen the little basket of peppers I have here. I have 3 different stacks, 3 different phenotypes. So, as I mentioned earlier, peppers spontaneously cross-pollinate. And sometimes when you plant things, when you pull the pods, as they first start to appear, the pod may not match what you expect to see on the plant tag. That happened to me last year, where I had something labeled giant cayenne. And it came up looking completely different. So I keep a spreadsheet, usually through Google Sheets, of what I have planted in the Garden of Apologies and where things are. Because no matter how good the markers are with my plant tags, after a bit of time in the UV radiation, they wipe themselves clear. And I end up with blank tags. Hello, Marmalade. It is always cat time in the Garden of Apologies. So the other good thing about having this digital map on the spreadsheet is that when I have something like this, that I was expecting to have come out as a cayenne pod turn into these. And I can follow that back from the previous year and see what the likelihood, see what the parents probably are, and sort of determine what may have happened. So I'm not 100% sure on the lineage and genetics behind these pods, but I'm quite sure that it was a cross between a Petit Marseillais, which is a little sort of amber golden bell pepper, an heirloom cultivar from France. I believe that got into my giant cayenne peppers. Your chocolate is in my peanut butter, so to speak. So when the pods came out last year, I was expecting them to look sort of like this, but instead I got pods that look like this. So the parrot, hello Louise. Still, it's always cat time. So let me talk about the pods and how the genetics work. So I'll pull up my little baskets here. The original pod, say, I don't have a Petit Marseillais I can show you, but it's a little, about a half-size bell pepper with a golden amber orange kind of color and a bit of a tropical fruit flavor. A really, really lovely pepper. Hint of smokiness to it. But for a lookalike, the giant cayennes looked quite a bit like this. Long, bumpy pods, a little bit of folding up at the stem end. And I'm calling them giant cayennes because I don't really know the full genetics. About 3 seasons ago, when I had a rough crop here, things didn't turn out well. Could have been 4 seasons. It might have been 2019, if I recall correctly. Digging back in the brain here. But I went down to St. Jacob's Farmer's Market, and I bought a bushel labeled cayenne pepper. And this is what I got. Pods very similar to this. Not this specifically, but pods that did look like this. Stay tuned for episode 9 of Pepper School, where I talk about the actual pod. But pods that did look quite a bit like this. Well, I saved the seeds, and I've been growing them out, and they have been coming out quite a bit like this. But last year, as I mentioned, I had a few of the pods that came out, plants labeled giant cayenne, or sometimes monster cayenne. The pods look quite a bit like this, so something completely different. This year, I planted the pods from last year I saved the seeds from pods that looked like this. I planted them this year, expecting to get pods that look like this, and I produced 3 basic pheno shapes. So the first off is this pod that looks quite similar to the pods I had last year. I also have this pheno shape, which looks quite similar to the parent pod from last year, or from 2 years ago, my apologies, from the grandparent pod of the cayenne. And I also have these short, squat looking pods. There, here's another one. So let me show you those 3 phenos side by side, just so you can get the idea of what we're looking at here. You've got the little guy, you've got the middle guy, and you've got the long guy. And that's where the genetics come in. Say, for the first generation, you assume equal parts of genetic background from parent 1 and parent 2. I suppose it's not necessarily an equal match, but you've got genetics from 2 parents. That's why sometimes you look like your siblings, one of you will look like your mom, one of you might look like your dad, and that's it. You've got 2 parents. When you get to the next generation, then you've got this guy here, which I'm assuming is a self-pollinating pod and not cross-pollinated. But assuming this is the right parent, then when you get down from the children from this is a parent of 2. And then below that, you've got 4. So as it comes down the family tree, it splits off. So you've got genetics from paternal father, paternal mother, maternal father, maternal mother. So you've got 4 components that then make up the father and mother of the 2 parents. And then you get down to the next generation, and it breaks down even further, where you get into your 8th and your 16th, and pods start to take on their own characteristics, you start to look less like your grandparents or your great-grandparents or great-grandparents, and you start to, as your own genetics sort of solidify into your own style, or as you pick up additional genetics from cross-pollination. Generally, it's considered the seventh filial generation, where things balance out. But you never know. Sometimes peppers stabilize earlier than that. Sometimes peppers, like things like a Carolina Reaper, never seems to stabilize, where you're well beyond the seventh generation, and you're still getting effectively a crapshoot on how the pods come out. You've got a pheno shape that you like. With the Reaper, you expect to have that little tail on it, but you get other pods that look more like this, like the white ghost shape, and some that look like a scorpion shape. So it's all up in the air. You never really know what you're going to get, and that's part of the fun of growing peppers. So I'll do another episode very shortly where I get into these peppers. I cut them open, and I give them a try, just to see what I've got in there and see what kind of goodness I have. But today, we're just talking a little bit about the plant genetics and how things come out. I haven't come up with names for anything yet, because until they're stabilized, there's really no sense. Because, case in point, you don't know what kind of pod you're going to see. Who do you get? Who's the child? You don't know. So there's no point in selling these seeds, and I think it's downright unethical to be selling seeds before you have them stabilized. I mean, I could have come up with a name of this last year when I had pods like this, and I'll start selling them. This is now an F2. This was an F1 pod last year. So here's your F1. I think I know what the parrots are. I'm going to call this a red fang. How's that? Just the first thing that came to mind. I can sell that. It leads to complaints, because people aren't going to get what they expect they're going to get. So if you're growing, you discover your cross-pollinations, enjoy them, have some fun with them, and enjoy the uniqueness. If you would like to cross-pollinate intentionally, then I'll follow up with another video perhaps, and I'll throw in some graphics. The basic premise is, because each flower pod, ow, damn it! That was Igor sharpening his claws on my leg. But each flower contains the male and female parts. So what you do is when the flower first opens up, you get in there with your tweezers and carefully pick off all the male parts that hang around the outside of the flower. And then find the parent plant that you want to produce, to contribute the pollen. Get over there with a little paintbrush and give the flower a little tickle. Then come over to the pod, the now stripped flower that has just the female parts remaining, and dust it with your paintbrush. And then ideally throw a little baggie over top of it and toss maybe a zip tie or something like that, elastic band, something that will hold the baggie on, not too tight. You don't want to cut off the flow of circulation into the plant or into that flower pod. But you do want to seal that off so you know you've got the right pollen in there and nothing from any of the other nasty suitors around your garden who want to get in there and get pollinating. And then when that pod grows out, you know that it's got the genetics from the host plant and from the donor plant. Save the seeds from that pod, plant them next year, and see what you get. But the way you stabilize these, just for conclusion today, is you choose the pod shape that you like. So I'm likely going to go with the standard pepper-shaped pod here, because it's the one I was growing last year. So pull the seeds from this, plant them again, find the seed from the next generation, the F3 next, that now has 1/8 of the genetics from the parent plant. Pull the seeds from that, plant them again, keep on going until you have pods that are growing out that match the pod they came from You now have a stable cultivar. Come up with a name, have some fun with it, and then send me the seeds so I can try it out. Thank you very much for watching. I'll be back shortly with another episode where I am trying peppers. But for today, I just wanted to talk about some plant genetics, just so you have a bit of an idea of what's going on out there in the garden when the lights are off and the party's happening. Thanks for watching. Please subscribe as you will, and I'll talk to you again next episode.